whenever an instance is created, there is an ID that is generated and it belongs to a storage, right? So I give this. So it says just main.employee. That's it. Under main.employee. And it doesn't have any ID at all. It means there is no storage in peculiar to this class. All right. So it will just be used as a logic generator for all the instances. Only when the instance is created, that's where you'll get a storage happening. All right. Now, emp2 is equal to, again, employee. When I execute it, so I try to print two instances. What happened? These two instances have different IDs, different storage spaces, but still these two instances are one and the same at the properties, but the values will change. Okay. Consider a table with millions of records. Even though it has millions of records, it has same headers, same column names, right? So same goes here. So for example, if I want to print something like emp underscore underscore date underscore underscore, forget about what this is for now. It will just give you the namespace. What is namespace in the sense? The locality of this instance, whatever it can do. All right. For now, it is having empty. There are no properties, which means that I cannot say that if it is empty, it is same. So I'll just add something else. So this will be instance class variable. So there it will still be empty, but employee is another object. So for every object, you have a namespace in OOPS. All right. So in employee object, we declared something called a is equal to 2. So that a is equal to 2 will be here. And the default namespace for the class will be module is equal to main, doc is equal to doc is pointing to none. Right. So this, what is this module is equal to main, we'll discuss in the next session. Have a note of it. But there will be something called def, dunder init, and then self. Let's say what an employee can have, some few basic details like his first name, last name maybe, and let's say his salary. Let's keep it very short. Now, you have to initialize this. init is a constructor in Python. So whenever there is a class, whenever you declare a class, it's just a prototype. Whenever you declare an instance, one, this instance, whenever it is declared, it will go inside the class, search for init method, initialize the variables, and sit silent. Whenever you declare another instance, it will still go to that very same class again, iterate over the init method, come back, and sit silent, and do whatever you ask. Okay. Now it is loaded up with the logic, whatever you see inside the class. If class is giving it this instance 4 superpowers, it will get filled up with those 4 superpowers, 4 properties, let us say, and then it has the ability to perform 4 properties. You can do whatever you wish in those 4 properties. All right. So for example, what is this? Init. First, you need to declare. What is self? I'll come back to it in a while. Self is just nothing but an instance name. It points to instance. All right. So whenever you declare self inside a method, it means that you are pointing to an instance. Instance, any instance. It can be any instance. Here, what are the instances? Employee 1 and employee 2. All right. So you are saying that an instance that is declared has to have 3 properties. 1, first name, 2, last name, 3, salary. right? When I say instances should have three properties, it should be instance dot first name. It should be the property. This is how we should use. All right, is equal to first name. Okay. But this instance, right? This instance is declared as self. Okay. But it doesn't have to be salary itself. I can make it as pay. Just declaring a variable as an instance property, and I'm passing the property to this function as salary. That's it, right? But to be very simple and to be very understandable, I'll just make it as salary for now. I can even say this as instance. It will even work. Okay. So now I'm declaring an instance, and I'm declaring instance properties inside an initializer, such a way that an instance, whenever it is declared, it will traverse through this init method and then will print off. Now when I execute it, you'll get an error saying that this init, this constructor defined, is expecting some 4 properties, right? So when I run it, it says it exactly takes 4 properties, but we give 1. Did we give 1 here anywhere? No, right? But why it is saying that we gave 1? Because instance is a default property, it will automatically go inside it, sit inside it. Okay. So first name, let's say Hari. Last name, let's say Kishan. Salary, let's say, what is this amount? 5 lakh maybe. So it's an integer. Now when I save this like this, okay, something. So we have 2 employees now with 3 attributes inside, 3 arguments inside the function. But as I've told you, instance is already a default argument. Now we have 4. All right, you got that? So now your namespace is filled with all these attributes. Previously your namespace is empty, right? What happened here? First, when employee 1 is declared, it is traversing through the constructor of the class. When it went through here, it created all these attributes. All right, but never do this kind of declaration. You have to name it as self. Okay, because it's a universal standard. People follow a standard, will have to stick with it. So now, even here, when I say pay, right, still works. Okay, but you see here, salary is 5 lakhs, right? So it is designated by salary. Now it is designated by pay, because the argument that you are passing outside of your function is having a name called salary, but you are redefining and redeclaring as an instance attribute with a different name. Again, I repeat it. The argument you are passing outside your function, outside your class, this one, right? This is a positional argument. The third position is having a name called salary, and you are naming that salary as another attribute, another variable, right? So it will take the shape of that variable. Going further, let us say, if you declare another method, and let's say print sal. Okay, so this also, okay, for now I'll just write it off and then I'll explain. Return salary is format of, if you say salary, All right. What will happen? Here it will not happen anything because the function is not called. Okay. Because we just declared it. Now when I say print underscore sal for an instance, right? emp1 dot the method name. All right. And it's a method, right? So how should it be? It's a function call, right? That's how you call a function. So it says salary is not defined, but is it the case? We defined, right? Salary is here. But when it comes inside a constructor, this is how it works. Not like this, right? So what you have to do, instead of salary, you will have to do self.pay. Got it? Now it gets salary is 5 lakhs for employee 1. Makes sense, right? Now there are 3 kinds of properties that I would want to emphasize more. When it comes to OOPS, functions are methods. Okay. Variables are attributes. You have to address every function as a method. You have to address every variable or an object as an attribute. That's it. Naming convention changes. The types of functions. You have 3 types of methods here. Let's say types of methods. Static method, class method, instance method. Okay. So these are the 3 types of methods. Likewise, we have kinds of attributes as well. Class attribute, instance attribute. So we'll discuss all of them in a while, but since we have come this far, let me just go back and okay, let's comment this. I'll just redefine this class. Now we have employee 1 is equal to employee, right? We have an employee instance. Employee 2 is equal to employee. We have 2 instances, right? Now if you want to declare the first name of an employee, you can do like this. emp1 dot first name is equal to Harry. emp1 dot last name, right? So emp1 dot some salary is equal to something else. Okay. Now if I try to print emp1 dot first name, I declared an attribute outside of your class. All right. So when I execute it, it will get, right? It will get printed. So if you want to declare another employee, what I'll have to do? I declared another employee called employee 2. Just have to copy this entirely, right? Now got it, right? So let's say some other names. Now if you see this, you got your employee 2 dot first name. So if you have to declare row by row like this in your class, it takes forever, large lines of code. I told you, remember, so we always follow dry principle. The code should be as dry as possible. What is dry? Do not repeat yourself, right? So for the same reason, we added it off like this, an initializer, which acts as a constructor in Python, but it's not a constructor. Okay. Which means if you are from another language, a class will not start if there is no constructor. But if you see here, there is no constructor, there is no init method, still it is working fine. So there are differences, right? So that's that. And again, if you say print employee1 underscore ICT, right? You got this? So it doesn't matter. So whatever you are doing here has been done with the constructor in the previous example, right? So we have declared self dot an attribute in the constructor in our initializer, but here we declared in the outside. Any which ways it will be added to the namespace. Okay. So okay. So these are the basic points, I would say. Yeah. Before we enter into the basics of OOPS, as I've told you, some few basic instructions. We are currently dealing with this one, okay? Instance method alone. We did not enter into static or class method at all, okay? So this instance method doesn't need any prerequisites. You just have to go ahead and declare a function, declare a method. We call it as a method, but this is one important thing you have to do. If you don't pass it as a self, right? If you don't pass the self, it means that you are not assigning any instance, right? So when you are not assigning any instance, it will for now show an error saying that it takes no arguments but one given. What is that one argument that is given to print underscore sal? That is an instance, because where it is given? Here. Okay. So when I comment this, it's executed, right? So here, what are you doing is you're passing emp1 dot print underscore sal, where your emp1 is yourself. Okay. So now this treats, in the absence of self, it is treated as a static method, but it is not a static method. Okay. If you want to make it a static method, you have to say static method. Okay. Now when you do is self is not declared. Why? When you say it is static method, it will not involve self at all, right? So this in line number 3 and 4 and 5, you have declared instance attributes which are peculiarly tagged up with an instance, right? It will operate only with instances, the self methods. So they are tagged up and they can perform your logic only when you are associated with an instance. All right. So when you are not instance like this, when you declare it as a static method, it does not include any instance at all. All right. So when it happens now, if you do this, it will still throw an error because pay is not defined, right? What is defined instead? Salary is defined, but this salary, the question is, will it live inside the class? It will not, right? Because this is just to instantiate from the outside, okay? Now what you can do in this cases, let's say sal, okay? Some sal. But in this case, you'll have to just say yes is equal to sometime 1000 lakhs or something. You're passing it as a regular method, right? So you're treating this print underscore sal as a regular method, and you're making a call for this. Got it? So this is the basic difference between static method and an instance method. Instance method is always tagged up with an instance. It always has self. Static method will not have self. Static method is equivalent to a normal Python function. All right. Cool. So now, when I declare an attribute here, what will happen? Let us say NodeDC position maybe, or let us give hike since we are talking about salaries, right? Hike can be, how much can we give? Maybe 20%. What is 20% of hike? It's like 1.2 into the actual salary, right? It can be, right? So if you say hike is equal to 1.2, a variable, I mean 1.2 into salary, it will give you 20% of hike, right? So when you say hike is equal to 1.2, did you declare any instance there for hike? No, right? How do you say that? There is no self dot, right? What will happen if I declare self dot? Will it work or will it not? First of all, any doubts till now? The online folks as well as the offline? I just need a comment from everybody, please. You can comment on the comment box. It makes sure that you are still listening, at least. Am I audible?
Yeah.
Cool.
No doubts.
No doubts? Everything is clear?
Yeah.
Cool. Good to hear. Vishnu and Pragna, you're okay, right? Because oops, the basics, the first session is very important. Vishnu, you there? Cool. Thanks for the response. I take it as you understood everything. So when you declare self.hike here, there is nothing, it will not even function properly, because if you are saying self.an attribute, it expects to be declared inside a constructor, an initializer. That's where you are initializing your instance, right? So you'll have to just give hike. When you say hike is equal to something, I mean a common attribute, it will be class attribute, right? So when you say class attribute, now let us create another function. Let's say hike sal. Let's keep it as instance function. I mean instance method. Return hike sal of employee is format of, all right, self dot hike. So what did I do here? I declared hike, which is a class attribute, but I printed this in return statement of a function of a method saying self dot hike. All right. What is this hike when it is done like this? First of all, let me debug this. Will it work or not?
How it will interact with salaries?
That's what. So how it will interact with salary? Oh, okay. You mean to say the formula is wrong. Okay, cool. So self.hike into self.pay will be my formula, right? But again, as I've told you, let's follow the standards. Salary, salary, right? Now, yeah, cool. Hike sal is a method, instance method. If you want to print hiked sal of employee1, employee1 dot hiked underscore sal of That's it. Since it is a return statement, you'll have to print it. Right? You got the hike. So if he's getting 5 lakhs, 5 lakhs of 1.2 is now 6 lakh. All right. I don't know the validity of it, but the formula goes well, right? So when you say hike and salary, salary is an instance attribute, hike is a class attribute. So it is working perfectly fine because it's, if you print employee dot underscore dict underscore and print emp1 dot namespace. Here is the thing. So a class attribute will have certain properties. When an instance is declared, every attribute comes to that instance, right? So a class attribute now has something called hike inside it, right? So this hike will by default be the property of this instance. Okay, so class is always superior. Where whatever you have inside the class, it is accessible with every instance. That's by default. That's how you can even say self dot, but you'll have to say employee dot to be specific.
Like
Yes, right. So what if you do like this? Can I just say that it's a static attribute and it works? It will not work because classes in Python or like any other classes, it can be prone to something called inheritance. All right. So inheritance in the sense, your properties can be inherited from your fathers, forefathers, like that, right? So here, this is standalone object. It can inherit its own properties from its own fathers, grandfathers, great grandfathers, right? So another class basically. So when it inherits it, when you address it like hike, who knows? Hike may be present in another class. So what if a scenario I'll tell you? There is something called A, B, C. Okay, A and B are the two parents of this C class. This class and this class, and this is a child class, right? So this class is inheriting all the properties of A and B. All right, A is having hike, B is also having hike. So what should be the hike of C? It's a confusion, right? So like that. That's why class dot hike will be there. Only then it will function. So to be more specific, you can also use self dot, but if you use self dot, what will happen? People who see your code understand that, take it as such that it is an instance attribute, but it is not an instance attribute, it is class attribute, right? We declare it as a class attribute. So let's keep that as is. Now, cool. When I now go ahead and say employee one dot location is equal to Hyderabad. Okay. Then I say print employee one dot location. So what happened? Employee instance has, sorry, what is this? So employee instance has a location called Hyderabad, right? So it means whenever you declare an instance, it will traverse only once inside its constructor, inside its initializer. You'll have to call it as an initializer, not a constructor. So whenever an instance is called, it will traverse through this and it will create all the properties of this mold, of this blueprint. But then you are always free to override and add more properties outside of your initialization. Okay. So now when you say employee 2 dot location, what will happen? Did you declare employee 2's location? No, right? There is nothing called location attribute at all for this instance attribute, right? Make sense? So that's why it gave an error saying that the location is not defined. So yeah, I'll quickly open up one thing and I'll discuss you with a PPT. So there are 2-3 PPTs that has to be discussed, after which you'll get a clarity and we'll get a hands-on on that as well. So we'll discuss about, we already discussed a few things here: creating and instantiating classes. What are class variable? What are instance variables? We discussed that as well. So whenever it is tagged up with self, initialized in init method, it will be called as instance variable. Otherwise, it is class variable. So we'll discuss about instance, inheritance, static methods, and class methods. Right. So class, needless to say, is just a blueprint. It's an abstraction. That's it. It's not a real-time object. It doesn't have an ID. Just a declaration of properties. All right. So when you declare it, there are 2 IDs. So this is how you have to revise also. Even after 6 months, let's say, if you want to look into OOPS, even I have to look into OOPS before attending the class. Otherwise, it's not like I know or not. It's like the matter is how I can explain it, right? So we should not miss any corner of the concept. That's why we will go to the summary of these PPTs. Yes, did we miss anything? Are we going to discuss this, right? So even before you enter an interview, you have to do this. Instantiation of instances and printing, it will give you different IDs. All right. And there is a technique to make sure when you print EMP1 and EMP2, both are pointing to same ID. So that is called as singleton data pattern, design pattern, we say. Singleton set, we'll call it as, which means it will have only one instance at a time active through an ID. So, but in general case, we can do that in Python only when needed, right? So it means that we are operating only with single active instance at a time. So initializing your variables, it can be done 2 times, 2 ways.
Any IDs like in real time?
Which IDs?
Now, employee 1 is given some ID.
This one?
Yeah.
Okay.
Given some other ID. So will there be any importance in real time scenario?
No, when it comes to ID, the only thing that you can think of is time complexity and space complexity, most probably. That's it. So when you are pointing an object to an ID and it is doing multiple operations, like for example, you declare A is equal to 2, B is equal to 2, C is equal to 2, D is equal to 2. You are saving a lot of space, right? Everything is pointing to the same ID. That's it. It will give you performance efficiency, but logically speaking, there is no significance at all. And singleton set, yes, this has a lot of significance. So when you implement using singleton set, it adds more security to your system, which means you are operating in a very secure, trusted port. You are only allowing one instance to calculate to enter into only one single port. Once it is initialized, ID is generated, right? This ID is sent to something called whitelisted IPs. We will say that whitelisted IPs are the IP addresses which a software allows it for the traffic to come inside. So we'll allow only one port at a time. That's very secure, like that. So we have different design patterns and different use cases, one of which is this. So if you want to do some concatenation stuff here, right? What I'm doing here, I'm declaring another attribute. It's just like string concatenation, right? So every other operation that you can use outside OOPS, you can also implement it inside this initializer. All right. So there is another attribute called email attribute that is with the concatenation of all this. Okay. Yeah. So if you do this, what is here? I missed saying this. That's why I follow PPTs. So class dot method of an instance is equivalent to instance dot method. So let's try that. What I'm doing here, instead of print emp1 dot hike sal, instead of doing this, what I'll do is employee dot hiked underscore sal of emp1. These two are one and the same that I will say. I'm saying that these two are one and the same because I'm calling a function inside a class with an instance as an argument, which is nothing but self, right? I'm directly passing self. Here I'm using self like this. Employee one dot hiked underscore sal. Here this is, it doesn't need any self at all here. The first argument itself is self because we are operating in initialized class. It is initialized class, which is nothing but instance. This is already, this employee emp1 is already referring to employee. But here, hiked underscore sal, this will not work, right? Because this hiked underscore sal belongs to someone, some class. It's not, the definition of it belongs to some class, right? So that class is not defined. Okay, does it belong to an instance? If it belongs to an instance, I can go and fetch that the class through which it is declared, right? So even that information is not there. Now when I do this, you'll get it, right? So this is the significance of self, to emphasize more. So you need to pass it like this, or you can skip self and pass it like this. Got it? So after this class, I would expect you to work on about half an hour or so. Let us say the task will be generate basic bike companies metadata. Okay, in the sense your class will be vehicle, all right, and then you inherit. Okay, for now, for today, just class is bike. Let us say the properties of bike will be in init, in the sense instance variables, all right. So bike needs upgrades. Okay, if at all there is an upgrade, another attribute will be added, instance variable. Let's say it gets ABS, right? Self dot ABS is equal to ABS, all right, like that. And if at all hiked price, I need to find out what is the hiked price of a particular bike. Okay, now how many number of bikes are there? Current scenario. Let's say you can take any company, any brand, doesn't really matter, right? So I need these basic info. All right, you can note it down, you can do pen it down, whatever. So maybe we can have a healthy discussion once you try it off. All right, you just need to replace employee with bike, that's it. And coming to number of it, right? Let's say number of employees is equal to 0. And how about number of EMP plus equal to 1? And then when I say print employee dot number of EMP. So what I'm trying to do here, I'm just trying to, why? Oh, okay. I'm just trying to print a value. Why? Equal to, let's say, Why this is not working? Should actually work. We can increment that way as well. So if you see this here, whenever there is an instance that is instantiated, right? It is traversing and incrementing the counter of number of employees. Initial, if I go ahead and say print here, all right, and here, all right. So for the first time, it is 0 because it is 0. All right. For the second time, you declared EMP1, so it went into init and initialized again. So incremented a counter. So now it is 1. That's how you are seeing 1, right? So for the second time, it is EMP2. It again went here, again incremented counter. Now, after it is declared, when you print this employee number of employee, it is 2, right? So this is one trick to find out the number of instances in a class, right? When you say bike, class is equal to bike. Each bike model will be an instance, right? Whenever you declare a new bike, it is like when you are declaring a new instance. And the properties of every instance, which is like a property of every new model, will be same as bike's properties. I mean the class properties, right? Maybe additionally, you may have another attributes or properties for few models, premium models. For that, what you will declare? You will declare explicitly here, right? Just like employee one dot location. Got it? So maybe you can try that out. You can have a healthy discussion. You can also try the same thing in your interested fields. So this is how actual database will be maintained in real time. So you can come back with any kind of implementation. We can discuss always. All right. So that's the end of today's session. Maybe tomorrow we will discuss more theoretical concepts and then we'll enter into the actual loops. All right. So we'll have to discuss more on the variables are done, right? We have to discuss more on static methods, class methods, inheritance, abstraction, and method overriding, overloading, like polymorphism concepts. And then what is multiple inheritance, how it is supported in Python, multi-level inheritance, just theoretical concepts, nothing else. This inheritance is nothing but fighting between the classes for properties, just like the people, how they fight for their properties, inherited properties, that's it. There is something called diamond problem, which will be the sophisticated problem in multiple inheritance, how to handle it. It's a very theoretical session, that's it. I'll not make it complex. If you wish to make it complex, we are free to make it complex. That's another thing, okay? So we'll discuss that in the next class. And hopefully I'll introduce you to something called multi-threading and multi-processing, and it will be the end of the session, all right? Yeah, any doubts? You're free to ask. Again, one more round of check. Vishnu, are you there? Radhika, is it clear?
Yeah.
Cool. Thank you so much, Radhika.
Thank you.